Welcome to another episode of Terry's Notes, and today we're going to be looking at the January 2017 paper, question 11. Okay, so in this paper we were given a matrix T given by C00D, and it maps the point 2, 3 onto the point 2, minus 3. Determine the value of C and D. Okay, so whenever you're given a transformation matrix and you're given a point, so the point is P and the image is Q. So if we are using the matrix method here, what we will have to do is to write the matrix first. So we're going to put D, sorry about that, hold on one sec. It should be 0, D, multiplied by the point P, which is 2, 3, and we know what the image is, which is 2 minus 3. So we need to set up this equation here first. So you have the matrix T up here, we have the point P, and we have the point Q. Alright, so what we're going to do, we're going to multiply. We're going to put row by column. So first row, so this row here, by this column. So C multiplied by 2 will give me 2C, and then 0 multiplied by 3 will give me 0. So it's 2C plus 0 multiplied by 3. So this will give me, that should be equal to 2. That's this 2 here we're talking about. So therefore 2C plus 0 is equal to 2. Therefore 2C is equal to 2. Therefore C is equal to 2 divided by 2. Therefore C is equal to 1. So okay, so we found C. Next thing we need to do is to find D. So again, we're going to multiply. We're going to take this row and we're multiplying by 2, 3. So 0 by 2, so it's 0 multiplied by 0 multiplied by 2 plus D multiplied by 3, which will give me 3D, is equal to minus 3. Right, I got this minus 3 from here. Right, just remember when you're given a matrix, right? So in this case, you're given a matrix T and we are given a point P. So T multiplied by P, as matrix multiplication, should be equal to Q. Right, and we always write the matrix first, right, before you write the coordinate. So 0 by 2 will give me 0 plus 3D, which is equal to minus 3. Therefore 3D is equal to minus 3. Therefore D is equal to minus 3 over 3. So therefore D is equal to minus 1. So therefore C is 1 and D is minus 1. So therefore the matrix T is really 1, 0, 0, minus 1. So that's the answer for the first part, to determine C and D. Then we have to determine the image of minus 5, 4 under the transformation T. So this is a typical question. So we know the matrix and we know the point. So we're going to take the matrix first, which is 1, 0, 0, minus 1, and we're going to multiply it by the point minus 5, 4, right, which is what we're trying to work out. So we're going to take this row and multiply by this column. So 1 by minus 5 will give me minus 5, and 0 by 4 will give me 0. So it's minus 5 plus 0. Then it's this row by this column here again. 0 by minus 5 will give me 0. And minus 1 multiplied by 4 will give me minus 4. So therefore the answer is minus 5 minus 4. So they wanted determine the image, right? So the image will be, the coordinate will be minus 5, 4. Right? Minus 5, 4. Minus 5, minus 4. Sorry about that. Alright. And now they want us to describe the transformation T. Now let's go back, let's do a quick sketch. In the exam, you might not remember what a specific matrix represents. So like this, if we look at the point P, let's draw a quick sketch. So the point P is 2, 3. So we know this could be 2, 3 here. So this is P, and this is the point 2, 3. The image under transformation T is Q, and it is 2 minus 3. So just by looking at the diagram here, you realize that Q is a reflection of P in the x-axis. So therefore, when they said describe the transformation T, it's a reflection in the x-axis. And those of you who can remember what matrix it is, whenever we have a matrix 1, 0, 0, 1, that represents a reflection in the x-axis. And then part 4 now, they said find a matrix that maps the point Q back to P. Right? So we had, this was P, this was our object, and this is our image here, Q. Now you want to map Q back onto P. Well, this is pretty straightforward. The matrix that maps Q back onto P is just a reflection again in the x-axis. So therefore, the matrix you're looking for is the same 1, 0, 0, minus 1. Okay? Next part of the question. We have, what is this here? We have, the graph below shows 3 points, P, Q, and R. And you have an origin O. Write as a column vector in the form XY, OP. So, we have, this is our origin here. And OP is represented by this line here. This is OP, right? So if we want the vector OP, all we need to do, if we start at the point O, we're going to go 1, 2, 3, 4 across. So we're going 4 to the right. So we're going to put 4. And then we're going to go 1 down. So this will be minus 1. Right? Some students might just watch what is the coordinate of P. The coordinates of P are 4 minus 1. Right? And they just write it in the vector form. What is QR? Where is QR? Right. So QR is represented by this line here. Right? So from Q to R, we are going 1, 2, 3 across. So it'll be 3. And we're going up now. So we're going 1, 2, 3, 4, 5. So therefore it's 3, 5. Right? Now they want to determine the magnitude of the vector QR. So the magnitude of a vector, so QR, is written as this. And the magnitude of the vector, since we already know what QR is 3, 5. So we're going to use Pythagoras Theorem essentially. So it's 3 squared plus 5 squared. We're going to find the square root. This will give me 3 3s are 9, 5 5s 25, which is the square root of 34, which is equal to 9 plus 25. That will give us 5.83 units. So it's 5.83 units. Right? So that is the magnitude of the vector QR. Pretty straightforward. Then this next part now, third part, they say, what do we want here? They said draw the vector OS, which is 7, 4. OS, which is 7, 4. So they told us that OS is equal to 7, 4. Right? What this means is that we start at the point O, and we are going 7 across. So let's start from the point O. So we have O here. So we go 1, 2, 3, 4, 5, 6, 7 across. and then we're going to go 4 up. So you're going to go 1, 2, 3, 4. So therefore this point here will represent the point S. Okay, so that's what they asked us to do. They said on the graph provided, draw the vector OS. So all we did was put the point S actually. So the vector OS will be given by this here. So this represents the vector OS. Okay, and they said to show that PQRS is a parallelogram. Alright, so where's PQRS? So PQRS is really going from here. Alright, so if PQRS is a parallelogram, it means that this here, QR, must be parallel to SP, or PS, sorry, and also QP must be parallel to RS. So let's start with the basic one here. So we already know QR. QR is the vector 3, 5. Let's find PS. So PS is equal to, now we can get the vectors just by looking at the diagram. So to get PS, we are going 1, 2, 3 across, and we're going 1, 2, 3, 4, 5. So we get that the vector PS is 3, 5. Right? So just by looking at QR and PS, they are the same vector, which means that they are parallel. So therefore, what this is telling me is that QR is parallel to PS. Okay, so that's one part of the proof we've done here. So two sides are parallel. Next thing we need to show is that QP and RS are parallel. So QP, the vector QP, how do we get that? Where is Q? Right, so QP, we are going 1 down, 2, 3. So since we are going down, it's minus 3. And we're going to go 1, 2, 3, 4. So we're going 4 across. So it's minus 3, 4. Right? So that is QP. Now we want to show that RS is parallel to QP. So we need to find RS. The vector RS will be, we're going to go 1, 2, 3, 4. So you're going hold on guys, I think I made a mistake here. For QP, I made a slight error. So QP is really 1, 2, 3, 4 across. So QP is not this. QP is 4 minus 3. Right? Always write the X values first. Okay? So RS was 1, 2, 3, 4 across, and 1, 2, 3 down. So that is minus 3. So the two vectors QP and RS are the same. So therefore QP is parallel to RS. Right? So therefore we can safely say that PQRS is a parallelogram. Okay?